So, what actually powers our modern world? I mean, really powers it. It's not just electricity, it's this deep, invisible connection between electricity and magnetism, a single fundamental force that, once we figured it out, completely reshaped human history. Okay, so here's how we're going to break it all down. We're going to start with the surprising discovery in a classroom, then see how we learned to tame that invisible force. From there, we'll see how it was used to create motion. And then, get this, how motion was used to create power, which leads directly to the grid that's powering your life right this second. Our story kicks off way back in 1820. You've got a physicist, Hans Ørsted, giving a lecture, and a pretty simple experiment he's doing is about to accidentally stumble upon one of nature's biggest secrets. So here's the crucial thing to get. Before Ørsted, everybody thought electricity and magnetism were two totally separate things. But what he found is that they're basically two sides of the same coin, a single force we now call electromagnetism. So check out the setup. It's just like Ørsted had it. You've got a basic electrical wire, and it's right next to a regular old magnetic compass. But the switch is open, so there's no current flowing. And nothing happens. The compass just does what a compass does and points north. But watch this. The second that switch is closed, current starts flowing through the wire, and bam! The compass needle just jerks to the side. This was the mind-blowing discovery. An electric current creates its very own magnetic field. And check it out. This isn't just some random fluke. If you reverse the direction of the current, the compass needle swings in the exact opposite direction. This proved the whole thing was predictable. It was controllable. And that, right there, is the foundation for pretty much every piece of technology we have today. Okay, so a twitching needle is cool and all, but how do you go from that little observation to a force that we can actually harness and use? Let's take a look. It turns out that magnetic field isn't just a chaotic mess. It has a very specific shape. The field lines actually form these perfect concentric circles around the wire. And understanding that pattern, that's the first step to getting this force under control. So, what happens if you take that straight wire and you bend it into a loop? Well, those magnetic field lines get all bunched up and concentrated on the inside. All of a sudden, that invisible force starts to get focused and way, way stronger. And if you take that idea one step further, you get this, the solenoid. By winding the wire into a really tight coil, you create an incredibly powerful and really uniform magnetic field inside. It acts almost exactly like a permanent bar magnet. This is the birth of the electromagnet. And here is why that is a total game changer. You see, a regular permanent magnet, well, it's always on and its strength is fixed. But an electromagnet, it's completely controllable. You can turn it on and off just by flipping a switch. You can make it stronger or weaker just by changing the current. And you can even flip its north and south poles. I mean, that's basically a superpower. Okay, so now we can create a magnetic field whenever we want, wherever we want. The next question is pretty obvious, right? Can we actually use this invisible force to do something? To make things move? And the answer is a huge, resounding yes. If you take a wire that's carrying current and you stick it inside another magnetic field, the two fields interact and the wire will get physically pushed or pulled. This one simple interaction is the principle behind every single electric motor on Earth. And of course, there's a handy rule for it. Think of Fleming's left-hand rule as the instruction manual. If your first finger points in the direction of the magnetic field and your middle finger points in the direction of the current, then your thumb points in the exact direction the wire is going to move. Simple as that. This is exactly how a DC, or direct current, motor works. It uses magnets to constantly give a little push to a coil of wire over and over again, converting that electrical energy into the spinning mechanical motion that powers everything from an electric toothbrush to a Tesla. So electricity can create motion. For a little while, that was the end of the story. But then another brilliant scientist, Michael Faraday, showed up and started wondering, could you run the whole process in reverse? He asked this totally revolutionary question. If an electric current can make a magnetic field that causes motion, could motion inside a magnetic field somehow create an electric current? And what Faraday discovered was that, yes, you absolutely can. It's a phenomenon called electromagnetic induction. Just by moving a magnet near a coil of wire or moving the wire through a magnetic field, you can generate an electrical current. No battery needed. The motion itself becomes the power source. And yup, you guessed it, there's another handy rule for this one too. This time, you use your right hand. If your thumb points in the direction of the motion and your first finger points in the direction of the magnetic field, your middle finger tells you exactly which way the new induced current is going to flow. This shows you the heart of an electric generator perfectly. It's basically just a motor running backwards. Instead of using electricity to make a coil spin, you use something else, like wind or steam from a power plant to spin the coil, and boom, electricity comes out the other end.
Now, this ability to generate what's called alternating current, or AC, is what really unlocked our modern electrical age. But there was still one final crucial piece of the puzzle needed to power the entire globe.
And that piece is the transformer. Using that exact same principle of induction we just talked about, a transformer can take an AC voltage and either step it up to a much higher level or step it down to a lower one. This simple device is the unsung hero of our entire electrical grid. So why is that such a big deal? Well, to send power over really long distances, like from a power plant to your city, you need incredibly high voltage to do it efficiently. Transformers let us crank the voltage way, way up for the long journey and then step it safely back down before it gets to your house. This is the main reason that AC, not DC, won the famous current wars. So think about it. We went from a simple, twitching compass needle in a classroom to uncovering a fundamental law of the universe. We learned to harness it to make motors, then we flipped that idea on its head to generate almost limitless power. This single force is the bedrock of our entire modern world. Which leaves us with one final, fascinating question. What's the next great secret it's waiting to reveal?